Now we are going to start with a small tool called Maven. Okay, Maven. Let's see how this Maven works. It is a smaller tool. It's a job role purpose also is pretty small. It's a small, unlike these, Jenkins, Ansible, Docker and all. It's a pretty small tool, but it is going to play a crucial role. Okay. Let's talk about Maven. What we'll do today, we'll discuss the theory part, and tomorrow we are going to see lab section of Maven. Okay. I have PPT, guys. Let me just open it up. Okay. Maven. See, Maven is a build tool. That already you know, right? Maven is a build tool. What is the meaning of build? Converting this entire source code into any installable application. That means WAR file. .war, web archive, any installable application. Entire IRCTC application is one WAR file. So WAR file contains index pages. That's what, web pages, backend database connectivity options, dependency files, images, everything, linking everything, group of everything is one WAR file. Okay, that is what WAR file that will be created by a tool called Maven. Okay, that WAR file, where we are going to run that one inside any application server. That is what Tomcat. That is what we are going to do it in project. Okay, so therefore don't worry about this one, where to run and all that you will understand later on. But as of to understand one thing, that the purpose of Maven is to create end product. That is what WAR file. That process we call build. Build means compiling, assembly, create, deliverable. That means compile means converting source code into machinable format. That's the first process. Then assembly, link, grouping all class files. The source code is right. First, it converts its code into machinable format. In that process, some files will be created. It will group all those files, and finally it will create end product. That is what .var. That end product could be .var or .jar. .var means web archive. Jar means Java archive. Web archive means any web applications, like IRCTC is a web application. To use this application, you have to use you access through browser and internet and all. Jar file means you can think of standalone applications. Like in my laptop, VLC media player is there. To run that VLC media player, I don't need internet. I don't need any browser. So those we call standalone applications. So either we can create WAR files or jar files. So which one will be created on what basis? The developers will decide. Okay, I'll tell you where. Actually, in Maven, there is a file called pom.xml, configuration file. Project object, module, project object, module or management, something. Just one minute. Right. Project object, management, model. Sorry. Project object model. Okay, yeah. So in Maven, actually, there is a configuration file called project object model. In that, these developers, they keep, if they keep WAR, then after build, you'll get end product called WAR. If they keep jar in that file, after building, we'll get a end product called jar. That is so that you'll understand just in a while. Okay. So the build means compiling the source code, assembling all files, related files, and creating end product. That could be either WAR or jar. Okay, these are the end products. That process we call build process. Okay. Advantage of build tool. There are so many advantages, guys. Earlier, people used to do build manually. Earlier. But now we got a build tool at Maven. So here we are getting many advantages. So what are the advantages of using this build tool, Maven? First of all, automated task. Everything will be automated. No need manual intervention. Complete automation. You'll understand what is this pom.xml. I'm going to explain. This is the main configuration step. Okay. Everything will be automated. This complete automation. No need manual intervention. That is one advantage. Correct or not? You remember In Jenkins, we have given that clean package. Just one Maven goal we have given. Everything has been done automatically, and finally you got one var file. Correct? That's it. Multiple tasks at a time. You take any tool can run multiple tasks at a time. Okay, that is one more advantage. Quality product, obviously, machine made things are always perfect. That's why quality wise it will be perfect. Minimize bad builds. I'm not saying that there won't be any bad builds. There will be bad builds. Because ultimately who is writing code? Developer is writing code, that too manually. So bad builds will be there. But when we build, bad code will be there. But when we build, if at all any buggy code is there, we'll get build fails, right? So we'll get to know immediately that code is buggy. Immediately we'll inform to developer will rectify that one, right? So development happens fast. Code bug will be rectified fast, development happens fast. Okay, because build occurs immediately, right? As when developers put the code in GitHub, right? So I'm not saying that we are eliminating bad builds. No, we are just minimizing those. That means bug will be reported fast, rectified fast. So development happens fast. Keeps history. Yes, Maven is a tool, it keeps history. Maven also, just like Jenkins. Okay, so that we can verify, for future reference and save time, save money. Obviously, it builds pretty fast within fraction of minutes or seconds. So that's why we are saving a lot of time. And obviously, time is money, we are saving a lot of money. And Maven documentation is a proper documentation. So any help that we need, we can get from Maven official documentation. These are the advantages that you get for each and every tool, whatever tool that you pick. Every tool has these kind of advantages, common. But why Maven became so popular? Because of these advantages, unique advantages. Okay, so for each point, I have separate slide for this. First, let me cover all those slides. Then I'll come back and I'll explain these points. Then you'll understand easily. Okay. Fine. So why do we need separate build team? See, developer is here. If he's spending 2 hours of time to write code, can't he spend 10 more minutes to build that code? If developer can write the code, he can build that code also. So bike mechanic is there. If he can, repair the bike, means he can drive that bike also. Correct? Here also developer can build. But why are we maintaining separate build teams in some companies? Why? Because of 2 reasons. The first one is to match customers' environment. See, developers, they write code in their own machine. Every developer, one in Linux, one in Windows. So as per their convenience. But build team, once development is over, they build. Okay, they build in a machine, whatever customer is using. If a customer is using Windows in that only they build. So that if they match environment, if it is working fine here, that will work fine in customer's environment also. Whatever customer is using, which configuration, that Windows or Linux or RAM, hard, what kind of configuration, the same environment will be maintained by build team. So that if it is working fine here, the product should work fine there also in customer's environment. That's the first reason. Build team worry about whole product. See, if at all any issues are there, this developer will say, hey, no, that is not my code, that is some other's code. Other developer will say, no, that is not my code, that is some other's. No one will be ready to take the blame if it is developer. But build team, developer, they are worried about the code that they have written. But build team worry about whole product. So responsible guy to clients. Okay, build team is worried about whole product. Okay, so that is the reason we are maintaining separate build teams in companies. Okay. Yeah, there are so many build tools are there. C, if you want to build C and C++ code, we have Makefile is there. If you want to build .NET code is there, we have Visual Studio tool is there. If you want to build Java code, we have Ant, Maven. Like for every language, you will get some build tools. If you want, you can search in Google, you'll get a list. Okay. 99%, 95% in companies, we are using Java only. Most of the cases. So to build Java, either we can use Ant or Maven. That's up to you. Ant is comparatively older. Maven is pretty advanced. Okay. Yeah, these two we use only to build Java code only, no other code. Okay, just remember that. So in project 1, we are going to use Ant. In project 2, we are going to use Maven, so that you will understand both tools. So coming to architecture of Maven, how Maven is going to work. Simple, guys. Here I am not using Jenkins. Okay. Now how it is going to work. This is Maven. Understand one thing. If you want to build any code, we need three things. First one is source code. Second one is dependencies. Okay. Third one is libraries. Okay. So libraries, if you want to build any code, okay, we need three things: source code, libraries, and dependencies. I think the same thing which I mentioned. Yeah, sorry, compilers. Compilers. If you want to build any code, you need three things: source code, dependencies, and compilers. Okay. See, source code is that should be compiled, then only that end product will be created. For that, we need compilers. Okay. And to compile, we need some dependencies, dependency files and all. Okay. Those also should be, we need to provide. If you provide all these three things, then Maven will easily create that end product. So what actually we do here, this is Maven. This source code we are providing from GitHub. You know, right? We are connecting GitHub with Maven. So that source code we are supplying from GitHub. See, these are source code. Now we need required dependencies and compilers. But what are the required dependencies and compilers? How does Maven come to know? So that dependencies and compilers information developer will keep in one file. That is what pom.xml, project object model.xml. This XML format. In this file, developer will keep required dependencies information, required compilers information, just information. Hey, I need these many dependencies. These are the compilers, and the end product, what you want, whether .var or .jar, end product. Okay, like a lot of information is going to keep. Okay, in that pom.xml. That means now Maven came to know that what are the required dependencies and compilers it need. Correct? Okay. Now what we do, who will create this file? Developer will create this file in XML format. Then goal means what you want Maven to do. Remember it, we have given goals, clean package, clean, that one, right? Those we call goals. That means what you want Maven to do. Okay, that is what goal. Whether you want just pull dependencies or you want to create end product. After that, you want to deploy what you want. So that we give in the form of goals. Okay, I'm repeating guys. To build, we need three things: source code, dependencies, compilers. Source code we are supplying from GitHub. Required dependencies and compilers information will be kept in pom.xml by developers. And goal is something that what you want Maven to do. This is an instruction that you are giving to Maven. Command, hey Maven, you do this one. That's one goal. So when you give respective goal, Maven needs required dependencies and compilers. Correct? Developer mentioned just names of those dependencies and compilers. But from where it will get actual dependencies and compilers? So those will be pulled from Maven's local repository called .mp. That's a hidden directory. When after installing Maven, you get this one by default. Okay. So whatever names he mentions in pom.xml, those will be pulled. Actual dependency compilers will be pulled from local repository. If they are not there in local repository, then those will be pulled from remote repository of Maven. From there, it will keep one copy of them in local repository. From there, it will pull. It's not like directly it is pulling from remote repository. No, from remote to local, it will place one copy, then local to Maven. So that in future, if they want same dependency compilers again, it need not to pull from remote repository. Directly, it will pull from local repository because already we kept one copy over there. That is how it works. Got it? I hope you understood. Okay. See, the main configuration file is pom.xml. For one project, there will be one workspace and one pom.xml. For one project. In our previous class, the project name that we have been test Java, right? Test Java repository. That's the project name. Okay. So for that, there will be one Maven, one workspace, that's one Maven. In that, there will be one configuration file. To create one end product, we need a Maven tool with one at least one pom.xml. Okay. Requirements for build. As I already said, if you want to build, we need three things. One is source code, which is already present in workspace that we are supplying from GitHub. Then compilers and dependencies will be pulled from remote report to local, from local report to workspace. That is how it is going to work. So I told you, right? Goal means this is something, this is a kind of instruction that you are giving to Maven. What you want Maven to do, that is what goal. What you want Maven to do. You remember, right? In our previous class, we have been MVN clean package, right? These are goals which we have done. Like the total, we can see many goals are there, but these are some important 7 goals. Okay, see, package is somewhere here. Clean is somewhere here. So what is the first goal? First goal, generate resources means if you give this goal, it will just pull dependencies. Maven will pull only dependencies. That's it. After that, it won't do anything. If you give 2 compile code, this goal, first it will generate dependencies, it will generate resources, it will pull compilers, then it will compile that code. If you give unit test, it will pull dependencies, it will generate it will pull compilers, and then it will do unit test also. Maven has a capability to test also. That means if you give second goal, 1 and 2 will be executed. If you give fourth goal, then 1, 2, 3, up to 4. It's like, whatever goal you give, in a sequence, previous things also will be executed. If you give 6, up to 1 to 6 will be executed, like that. Package means after testing, it will create end product, means that war file. Okay, let me show you. In Maven class, in Jenkins and Maven class, we have given MVN clean package or clean package goal we have given it. Package goal we have given it. That means unit test also executed, then only it will created war file. Okay, let me show you. Go to Jenkins, go to Maven job. See, go to any build. You can see here somewhere you will find tests. You can see tests got executed. Then after that only, finally, it created war file. You can see that is it. Then install means after creating that war file, if you give install, all these will be executed. That we can keep in any place. The place where we store war files that we call artifactory. That end product we call artifact. End product we call artifact. Those we store in artifactory. If you want, you can store. If you attach any artifactory with Jenkins, if you give install, then end product will be automatically stored. Deploy means directly that war file can be deployed in end product, end servers like Tomcat and all. Okay, automatically. After storing one copy, another copy will be automatically deployed in servers. Like that, whatever, if you use 6th goal, all remaining 5 will be executed. Like that. This clean is not a default one. You can see 1 to 6 default and will be executed in sequence order, but not 7. 7 is not a default. It won't follow sequence. That's why we have been clean separate. What is clean? When you give clean, it will clean up existing war files and that files and all, and it will create fresh, new. Like, see, I have when first I'll give MVN package. Okay, one war file got created. Now you modified that source code again. You want to give this command. That time, if you give this command, one more war file will be created with another version. But I don't want that. If I give clean second time, that existing files and war files will be deleted and it will create fresh war file. That's why we are giving clean. Before it creates war file, it will clean existing things. So 1 to 6, these are default. The 7th one is it is not a default. That is how it works. Okay. These we call goals. Goal means something what you want Maven to do. That is what we call goals. Now coming to Maven directory structure, it is something like this. Outermost name would be the project name. As per our thing, test Java, that repository we created, right? Test Java in GitHub. So what actually happens, I'll tell you. Developers, they write code, right? These are developer machine. This GitHub. Okay, this is Jenkins. Developer, they write code, they push code to GitHub. Jenkins will pull that code, it will do the build with the help of Maven. But in order to build with the help of Maven, the source code should be present in proper directory structure. So who will create the directory structure? Developer will create directory structure in their laptops, and they will push the directory structure itself into GitHub as it is. So directory structure is very, very important for Maven in order to build. Otherwise, Maven cannot build. So that should be something like this. Project name. Inside, there will be one folder called SRC, means source code. These you cannot change the names. And equivalent to the directory, there will be one file called pom.xml, project object model.xml. So one folder and equivalent to that one configuration file. Inside SRC folder, again, two folders, main and test. Inside main folder, developer, they are going to keep source code. They are going to dump source code. See guys, testing happens at every stage. Testing happens at every stage. So developers also, they do test. Okay, developers, they do test. Build team also, they test once from their side. Test team also, they test. Okay, build team, they test means, Maven will test automatically like this. Okay, Maven tests automatically like this. Test team also, they test separately from their side. And deployment also, they test. Okay, testing happens generally at every stage. So developers also, they test. For that, they write some test cases here. Those test cases they keep here. That means whatever source code they keep here, for that related test cases will be written here. Those test cases will be applied on this code and where that will be tested. That's why you can see app.java, app test, application test.java. Source code will be placed here in main folder. Test cases will be kept in test folder. The directory structure is mandatory. Then only things will work. Let me show you in my GitHub. Test Java. If you go inside test Java core, you can see SRC and pom.xml. SRC, pom.xml. Inside SRC main and test. You can see main and test. Inside there could be many other folders. Okay, you can see main and test like that. The structure is mandatory. Okay, then only Maven will recognize that code. I told you that there are two types of repositories. One is local and one is remote. Local repositories .m2 that by default you'll get after installing Maven. Okay. Remote repository is this one. These are places from where Maven will download required compilers and dependencies if they are not there in local repository. You can see these are places. You can see a number of things are there, right? From where it will automatically pull required compilers and dependencies. Okay. So pom.xml contains like this. These are the things. It contains required dependencies and compilers that already you know. Then what kind of output, whether you want .jar or .var, and some information about that project. What kind of project it is, Maven project or what, any Ant project, any that one. Some information, whatever developer they keep. It's kind of metadata, or you can think of description also. You can see a dependency information like that. Okay. You can see Maven var. I'll show you. You open any plugin. Sorry, you open any pom.xml, you can see. Okay. Okay, this is how it actually looks like. This kind of, okay. This is how it looks like. Pom.xml. Okay, who will write this one? Developers, they write. Okay, developers, they write this one. Okay, yeah. You need not understand what they write in pom.xml and what the source code they keep. That's unnecessary for us. Our job is, I'll show you practically, I'm going to show you right tomorrow. That time you'll understand what you are going to do it here. But you should know at least what is what. I told you right in my demo, I said you should be perfect in 1 or 2 tools or 2 to 3, but you should have knowledge in all the tools. So Maven is one such tool where you need just knowledge. Okay, you should know at least how it works. Okay. Yeah, some important points you must know. Maven is all about plugins. See, when we give any goal, suppose if you give package, backend respective plugin will be executed actually. Okay, respective plugin, package plugin will be executed. So it's all about plugins. When you give goal, backend respective plugin will be executed. Okay, then you'll get proper output. That's it. So in Maven, see, there are 2 concepts out there. One is snapshot. Snapshot indicates development copy of your project. Like you can say here, when you build, 1 second. If you observe carefully, that end product name is going to be something snapshot dot what, something it is showing, right? Snapshot something, right? Snapshot dot what. So snapshot indicates development copy. It's not the final copy, not final copy. For example, IRCTC is here. To build IRCTC website, some 5 modules are there. So each module, when they build, one small war files will be created. Okay, so that time those going to be snapshot.war. Snapshot indicates development copy, which is under progress. Okay, developers, when they write the code in pom.xml, they keep snapshot. They use a word that indicates that end product is not ready yet, which is under progress. Okay, once everything is ready, then they combine all that code, combine all that source code, then finally they build. That is going to be again the final end product. That time there won't be any snapshot. See, instead of giving snapshot, they give version number. If you see version number in place of snapshot, it means product is ready to give to customers. Like you take any product case, for example, you might have observed, you take any end product, that will be in the form of some version number, like Git is there. Git latest version is something dot something dot something. Ansible also something dot something dot something. You take any end product. Okay, so for example, Git downloads. You take any end product, you will find one version number over there. You can see what is this 2.34.1, correct? Something dot something dot something. So you take any product, it will be in the form of 3-digit number. Okay, so when you see snapshot, okay, when you see snapshot dot var, once build is over, that means that is not the final var file. That's the meaning. If you say version number, then that is a final var file. That's a full and final. So developers will keep that information in pom.xml. So what is the meaning of the 3-digit something or something? The last one we call patch. The middle one we call minor. The first one we call major. Simple guys. Okay, let's take Windows. Windows 10 is there. Windows 10 means actually the full form is 10.0.0. Suppose they keep on upgrading this one, right? When they release any patch updates. What is patch? Small changes, minor tinkerings. Suppose road is there. Oh, there is a small hole is there on road. So that hole we fill with with some, any sand or whatever, stones or something, right? That's what patch. Okay, small changes. That is what patch. Okay, they fill patches and all right, the road. Okay, that we call patch. Small changes. When they release, when they modify that WAR file with small changes, then they increase this number. That means patch update. Minor means some good number of changes, like they have modified entire MS Office. They modified entire MS Office. That's not a patch. That's a minor one. So they change this. If they modify entire OS itself, Windows OS itself, they change this one, 11. So 11.0.0. That's it. So patch, minor, major. So as per the requirement, they change this number when they modify that. That's it. Yeah, in Maven, we have one more advantage is that we can have multi-module project. Multi-module. See, if you take IRCTC, it is so big project, so big. In that case, building that entire IRCTC in one module is difficult. That's why they will subdivide into multiple modules. Dividing big project into multiple modules. If it is so big, then they divide into multiple modules. Okay, multiple modules. So that we call multi-module project. Simple. If project is so big, then that we can divide into multiple modules. Okay. For example, if you take banking application, in that net banking is one module, loan section is one module, insurance is one module, credit card is one module, credit card department, debit card department is one module. Okay, like so all these options are there in banking website, correct? So that time what we do, we divide, we building this entire application in one go is a bit difficult, correct? That's why they break this big application into multiple modules. So one team, they work on net banking, and that team, they work on this one, like that. Okay, like that. So we can divide project into multiple modules. Okay, maybe same team work on multiple, all these things, same team may, but that time to have proper segregation, they will divide into multiple modules. Like this is banking application, this is net banking, this is credit card department, like that. So dividing project into multiple modules, that is what we call multi-module project. So every module is a kind of mini project. You'll see every module will have its own SRC, pom.xml. Every SRC folder will have main and test folders. Like that. That we can have if your project is so big. Okay. See, simply dividing project into modules. That is what multi-module. So each module will have obviously its own SRC folder and pom.xml, so that build happens separately. Correct or not? We can build each module separately because each module is a kind of mini project. It is having its own SRC folder and pom.xml. Okay. Once it is everything is over, building all modules, then finally we combine all those things and we build all modules in one go. Once small builds are over, if no errors, then all modules we can build in one go. Okay, clear? Building individual modules. Okay, then once it is successful, no error, then we can build all modules in one go, one command. So for that, there should be a parent pom.xml file. See, this is big project, module 1, module 2. Every module has its own SRC in pom.xml. SRC, pom.xml. So if you want to build all modules in one go, there should be a parent pom.xml file. There should be a parent pom.xml file. So in that we keep, developer, they keep all these modules information one by one in sequence order. So when you build this module, this project, big one, then these small modules will be built automatically in a sequence order that you mention in parent pom.xml file. Simple guys. One big project, can be divided into multiple modules. Those anyways you can build separately. But if you want, you can build all these modules in one go. Okay, in that case, these modules information you should keep in parent XML file in a sequence order so that you can build this project in one go, so that all modules will be built one by one in the order that you mentioned in parent XML. Okay, see, in parent XML file, you need to mention the child XML files in an order. Yeah, this you should know what is what, but this everything will be taken away by developers, because they are going to write the code, they are going to store the code in GitHub. See, we are worried about after reaching code to GitHub. So when we get code in GitHub, that we get with proper directory structure, the way we got like this. Here you can see. Okay, we already get in a directory structure. So who will create this directory structure? And a developer they create and they push to GitHub. So they're responsible actually, but you must know how things work. Okay, got it? That's it. So this is a theory. I skipped some important points, right? I said I'll explain after discussing all slides. Yeah. You can see Maven gives set of standards. Means proper directory structure. There's a standard established directory structure. You take any Maven project. Okay, that is project name, then src, form.xml, inside main test. This is a standard directory structure. That means if you know how to build one project, you can build any number of projects because structure is pretty simple. So it is giving proper standards. Gives defined project life cycle, goals, fixed goals, clean package, clean install, fixed goals. Okay. And it automatically manages all compilers and dependencies. Just developer has to mention the information in Pond.xml. Everything will be taken care automatically by Maven. Just you have to mention the information. Uniformity in all projects. Why uniformity? Because directory structure is same. Goals are standard goals. So there's a unity in all projects. Same directory structure in them. That means if you want to build one more project, okay, developers for them, it would be easy because they can copy and paste this directory structure. Just they need to change the source code only. The directory structure is same. That's it. Reusability. Yeah, we can reuse. That's what directory structure, dependencies and all. Once some dependencies and compilers which are already there in local repository, then it won't again pull from central repository, correct? So we can reuse them again and again, correct? That's why you might have observed for the first time when we build Maven project, that time it took good amount of time for the first time. Okay, but when we built second time onwards, it did not take much time because required dependencies and compilers already kept in local repository. From local repository, it pulled from second time onwards. You can see. Let me show you. You can see. Required dependencies and compilers second time onwards, it directly pulled from local repository. But for the first time, these were not there in local repository. That's why it pulled from central repository. But second time onwards, you can see it pulled everything from local repository. That is how actually it works. Got it? Okay, these are directory structure actually. I mean, these are theory of Maven. What we'll do tomorrow, we'll be doing this on practical. Practically, I'm going to show you. What I'll tell you. I will take one developer machine. We'll take GitHub and we'll take Jenkins. In that we keep Maven ready. And GitHub will be there. So this developer machine. Here also Maven should be installed. Every developer machine will have Maven. That time, how developer is going to create the directory structure? How they are going to keep that code? Then after they'll add, they'll commit and they push to GitHub. Immediately how Jenkins will pull that directory structure, the code and complete directory structure. And with the help of this Maven, how it creates any product. And all that flow I'm going to show you so that you will understand how they create directory structure and all these things. So that you'll get complete picture how developers they are going to work, what they are going to do. And in this, what is going to be your role. Okay, that is what I'm going to show you. So tomorrow main focus will be on Maven. Okay, so that takes entire class actually that we'll be discussing in tomorrow's class. Tomorrow you'll get complete picture. Okay, how Maven works. Okay. Yeah. So these are theory of Maven.